like it is good. Let me pull this window across so I'm not looking at two different places. You might see the background behind me is a little different than normal. That's because I've taken down all the lights and everything in order to, since I'm no longer taping any of the pre-recorded videos, so this will be a little more au naturel, if you will. But hello everyone, welcome to week 13 of the introduction to ABM. Hopefully everyone is on board and seeing all this. Going to send out some tweets and some forum posts just to make sure that we get whoever, if anyone was missing it. So let me do that real quick. So introduction to agent-based modeling office hours are starting now at, and the URL is youtube.com/live/BillRand. You guys should all know it if you're seeing this, but just in case. /BillRand/live. I screwed that up. Makes sense that it'd be the other way around. Okay, you guys should all know it. So, sending that out. And we should be good. Just gonna get that set up too as well. Okay, I can do that while I'm talking. So, since hopefully everyone was able to get in their last assignment, so that was all good because that was the last assignment, major assignment. Now you should be having, you have the next 2 weeks to complete all the last details of the class, and that includes all the exams as well as the peer reviews, right? So I want to go over the peer reviews a little bit because that's something that people seem to be having a little bit of troubles with. But essentially, there's a couple of issues that have come up. First of all, just to go over the basic rules, you have to do 3 peer reviews to get full credit for the final project. The peer reviews are worth 1/3 of your final project grade. The actual final project is worth 2/3 of your final project grade. So that is the way it works. You can potentially do more than 3 peer reviews if you want to help out with other people, but but you have to do at least 3 just to get to where you are. Just trying to check gains. I'm clipping a little. Okay, there we go. So do 3 peer reviews within the next 2 weeks. I know a lot of people screwed up the deadline. And so let's just be utterly and completely clear about the final one. The deadline on the actual assignment will say that it must be turned in by November 7th. What that actually means is it needs to be turned in sometime on the day of November 6th, right? In other words, you have to get it in before 12:01 a.m. on November 7th. So you have to get in by 11:59 p.m. on November 6th, basically, or however the exact minutes around their work. I would highly recommend getting in before 10 minutes till midnight on November 6th. Okay, so hopefully that will help you help make sure everyone gets it in on time, right? Other details about the peer review assignments. The way the peer assignments work, right, is that when you basically get your assignment, you will download a file. That file has an ID number. I think it's 5 digits, but I don't know 100% for sure. You should make sure when you submit your assignment that the 5 digits on the download matches the 5 digits on the rubric that you're now assigning the grades to, right? Because essentially the way it works is that if for some reason you go away, if you time out, if you reload that page, if your browser automatically refreshes the page because you clicked away and clicked back or something like that, it will give you a new model if and only if the previous model already has 3 reviews submitted for it. So it won't always give you a new model, but in some cases it will. So make sure that those 5-digit numbers match up. The best way to do it is just to do it, kind of do it with the model up and running. Now that being said, people have had some small problems because apparently some students did not do their assignment in NetLogo 5.3.1, but instead used some other version of NetLogo. If they did do that, when you open the .NLogo file, it should tell you what version it was written in. Almost all of the versions, all the compatible versions, are up on the ccl.northwestern.edu/netlogo website, right? So you should be able to get any of the NetLogo assignments from there, any of the NetLogo codes from there, any of the previous NetLogo versions, including NetLogo 6, which is one it seems like people have done the most with. They've been like, oh, I want to get on and use the beta. Well, we haven't been using the beta for the class, so it's been made it a little complicated for other people, right? But you should be able to grab all of them from NetLogo's website. If you can, it would be a great help to us if you went and downloaded them and installed them on your machine just for the purpose of running that code, checked it over, and then graded it appropriately, right? You can have multiple versions of NetLogo installed on your machine. It won't overwrite the version you have already when you add a new version. And in fact, this is a good way if you ever want to open two NetLogo files simultaneously on a Mac. One of the only ways to do it is to have two versions of NetLogo installed and open them in two different versions. Small little hacker trick to getting that working. But anyways, I would ask you all to do that. If for some reason, no matter what you do, you can't get the version, the right version installed, you can't get it loaded, please send an email to abm@complexityexplorer.org. Tell us what that 5-digit ID number that you had was, and we will look into it, try and handle it manually on our end, okay? So do all your peer reviews. Try and find the right NetLogo software if you can to handle the peer reviews. If you can't, send us an email. Other than that, that should solve most of those issues, right? Okay. Now, the other thing is that November 6th is also the deadline for for all of the exams. Okay, so please, make sure you've got everything done. The rule is that you have to have greater than a 70% completion rate on all the exams and all the assignments, right? So this means you can, by the way, get a 0 on one assignment because under the current weighting, there are 9 exams plus the final project, right? So you can get a certificate even if you didn't complete one of the exams. You just have to do that much better on all the others, right? So each exam and the final assignment winds up being worth 10% of your overall grade, and you have to maintain a 70% or higher in order to get the certificate, okay? Let's see, that's about it for general announcements, I think. This is we're wrapping up in the last 2 weeks. There are no more new videos besides the office hours that I will be posting. Oh, one small note, I was looking over all the videos, making sure they were all in order. I noticed that on the playlist, 2 of them weren't there. So for those of you who only listen from the playlist, I've added back in week 3 and week 11, I think it was, and put them back in the proper positions in the playlist. They will now be up there, but you can always go and grab them individually. If you just go to youtube.com/BillRand, they're all posted there. Right. So I think that's it for all the general announcements. I'll go through and look for specific questions going next. So first of all, I want to thank our live viewers as always. So thank you, Eugene, John, Jim, Martin, Jerry, Gustavo, all for joining us this morning. And it looks like some questions have already been submitted on the live stream. So I'll go through those first, and then I'll switch over to the emails and the forums. So Eugene asked about, can you tell the difference between ABM and Mac? I assume you actually mean multi-agent systems, not MAC, and why different software is used for each of them. Sure, Eugene, I think I briefly touched on this in one of the other office hours, or maybe in one of the videos, but it was very brief. There's a long-standing, there's been 2 different but related communities that have existed around multi-agent methodologies for a long time, right? One of those communities is agent-based modeling. Agent-based modeling tends to primarily be composed of people who aren't in, I don't know if I want to say that. It's composed of more of a uniform sampling of all the disciplines, right? So rather than being strongly emphasizing one discipline or another, it's kind of people from all the different disciplines, right? Multi-agent systems tends to primarily be people in engineering and computer science, and I'll tell you why in a second. The goals of the two communities are somewhat different. Agent-based modeling, really the goal is to model or represent using agents a natural or social or engineered phenomenon of some sort, right? So, like, how can we best describe something like traffic jams? How can we best describe ant colonies? How can we best describe something like flocking models, right? Or information diffusion, right? Multi-agent systems, but in these cases, the agents are not usually engineered agents. They're not agents that are meant to achieve a particular goal in the sense that they are virtual agents we're going to embed into another system. They're instead representative of agents that exist in the real world in some sense or another, right? And so to that extent, right, the agents in an agent-based model are representative of other entities, let's put it that way, right? In a multi-agent system and engineering approach, often the agents are actually virtual agents that will exist in an electronic format, in a computer program format, right, in an actual system, right? So for instance, if I want to program a bunch of agents who I want to coordinate to, for instance, help me out with travel planning, there's a classic game where this was done called the trading agent competition that was originally put together by Mike Wellman and some colleagues at University of Michigan. If that was my goal, if my goal is to have agents trading in an optimal fashion or achieving some sort of optimal objective, right, then the agents themselves are the things they're representing. There is no difference between the agents and what they're representing, right? They're not supposed to represent other traders. They're supposed to represent an optimal trading agent, right? And so a lot of times in multi-agent systems, that representation distance is different, right? As a result, the goal is often different, right? In agent-based modeling, the goal is to provide some insight into the way the real system operates or works. In multi-agent systems, the goal is to engineer a system that achieves some optimal goal, right? Now, that distinction is a little blurry at times, right? Because agent-based modeling, often we want to describe a system and then see what kind of incentives we can provide to tip the system or nudge it into a particular attractor, right? A particular state of the world, right? But the idea is we don't do that by changing the rules of behavior of the agents, right? We do that through what some people might call mechanism design, right? We're trying to create an incentive, a mechanism that will cause the agents, under their current rules of behavior, to operate differently in a way that we feel is optimal, right? And so that's a slightly different perspective. In multi-agent systems, we are literally rewriting the rules of the agents often to have them achieve some sort of specific goal, right? So why do they have different software? Why do they use different? Well, they don't have to. First of all, let's make it clear. Both agent-based modeling and multi-agent systems could use any Turing-complete language and even some non-Turing complete languages to operate, right? They could work in those spaces, right? So you could write an agent-based model in C. You could write a multi-agent system in C, right? No problems there. However, as came up on the forums, I think this is what Eugene is referring to, there's a package called Jade out there that's very popular for multi-agent systems, but not used much in agent-based modeling. And to tell you 100% of the truth, I don't know Jade very well, right? I know most of the ones that have been specified for agent-based modeling, but allow me to speculate a little bit as to why they might have different goals, right? And give me another example. SOAR, for instance, is a system that is really meant for multi-agent systems and not really meant for agent-based modeling. SOAR, developed by John Laird and many other colleagues at Machine as well. Right? So SOAR essentially has these systems built into it that allow agents to do very complex reasoning about the way the world is, right? So it's, for instance, allowing an agent to figure out, given that I have all these actions I can take, what is the best possible way for me to achieve my goal, right? That's great when your goal is to build an optimal agent platform, right? When your goal is to describe a real-world environment, that the speculation by a lot of people who develop agent-based modeling is that that's not the way people actually make decisions, right? SOAR almost in some ways represents the more Homo economicus worldview, right? The worldview that says that we have infinite capacity to reason, and though in SOAR it's not infinite. Don't get me wrong, right? That we have this ability to really optimize all of our decisions, and a lot of the agent-based modelers feel that that's not the way people actually make decisions, right? That they make it through heuristics, using boundary rationality and inductive reasoning, right? And so that's a very distinctive perspective on the way they do, right? So as a result, a lot of agent-based modeling is written in such a way as to facilitate that kind of transition, that kind of analysis. Another thing is that a lot of times in multi-agent systems, right, because these are designed and built for engineers and for computer scientists, the languages don't necessarily have to be as easy for a non-computer science or engineer to understand as a stakeholder, right? And as a result, they kind of give up some translation capability, right? Some easy interpretability, in order to make the code as efficient and optimal as possible. So anyways, that's that. I don't want to emphasize too strongly the distinctions between ABM and MAS, right? I think that there's a blurry boundary, and you could see the fields merging. If you go to the biggest conference for MAS, is a conference called AMAS, Autonomous Agents and Multi-Agent Systems. If you go to that conference, you will see people presenting agent-based modeling work, but it will be in the minority of the work there. The vast majority will be more on this multi-agent systems engineering perspective. Hope that helps, Eugene, and great question for sure. Jerry has a question. He wants me to talk a little bit about the ODD protocol. And let me bring up the ODD protocol. I think I've done this once before in an office hour, but just to mention it. The ODD protocol, let me bring up the window. It was a protocol developed by Volker Grimm, Steve Railsback, and a bunch of other people, Gary Polhill, Tom DeAngelis, Uda Berger, many others had a role in this. So let me bring up a picture of, this is not the original paper, but it is a prominent picture in this space, right? Trying to find the right one. Make sure I get it right. Ah, there it is. Okay. Okay. So, so this is a prominent paper about the ODD protocol, right? And it basically describes the fact that, sorry, didn't mean to flip away like that. It basically describes the fact that after it had originally been released, some discussions about it, right? The ODD protocol, let me start by explaining it there, was designed to provide standards for how people would publish their agent-based models in such a way that they could describe them for other people to understand them, right? Now, I have a different paper that I published with Roland Rust that was in the space of marketing that provides guidelines that people often say are competitive, but they're not. The point of the ODD protocol is to talk about publication standards. The point of Roland and I's paper was to talk about how to make sure your model is validated and verified. They're related issues, but they're not necessarily uh, in competition with each other in any way, right? So the ODD protocol stands for Overview, Design Concepts, and Details, and I'd say it's probably one of the most comprehensive and best written design documents. Now, there is some discussion about how to best use the ODD protocol. So first of all, the ODD protocol, though it's meant for describing an agent-based model in a publication format, it's not clear that it should actually, for instance, be in the main text of a journal article. It makes more sense, I think, in many cases to have the ODD protocol in an appendix that for those individuals who want to look at the model in more detail, right? So in those contexts, I think it makes sense to have the ODD protocol as an appendix, if you will, right? So what does the ODD protocol actually look like? Let me see if I can blow this up a little bit. Oh, there we go. So here is the basic ODD protocol, and as you can see, it was originally published in 2006. This version of it was done in 2010, right? And as it states, right, the ODD protocol is divided into three components: the overview, the design concepts, and the details, right? And in the overview, you would specify the purpose of the model, the entity, state, variables, and scales, the process overview, and scheduling, right? And if you notice, this has a lot of parallels to what I've asked you to do in your final project. And in many ways, they're related, right? Because I want you to be thinking in these same concepts. Now, I don't go into as much of the detail about the ODD protocol I don't go into all the details, but if you were to take the documents I'm asking you to write for your final project, or I ask you to write for your final project, they would fit nicely into the ODD protocol. You could basically map them in many ways into it, right? So the design concepts include discussing things like what are the basic principles, what emergent properties exist in your model, what adaptation exists, what are the objectives of the agents, right? What learning and what prediction does the model do? What sensing elements do the agents have? How do they interact? What stochasticity is there? Are there any collectives, right? Are there any agent sets that are very important? And what things can you observe, right? And then finally, in the details, you need to discuss things like how did I initialize the model, what was the input data, and what, if any, submodels exist, right? And it's been very successful. In fact, there are many journals out there that are starting to consider, well, I don't know many, but there are definitely journals out there that are starting to consider using the ODD protocol as kind of a requirement, in some ways enforcing the use of the ODD protocol to document your model, right? I highly recommend if you're submitting, it's a good way to do it. I do it myself. I use kind of a hybrid of some of the versions that we talk about in the textbook and the ODD protocol, right? And I think it provides a nice explanation of the model. The goal of the ODD protocol in many ways is to enable reproducibility, which is something I totally support, right? I believe that your model should be documented in such a way that it is easy for someone else to reproduce what's going on with it, right? And you know, I think the ODD protocol is great. I don't have any real problems with it. I feel like, you know, if I was going to leverage any kind of minor criticism whatsoever, it'd be that in many cases not all the componentry is necessary, right? And so it's a little overkill for some cases, but you know, better to be more explanatory than not explanatory enough, right? Anyways, that's the ODD protocol. Great question, Jerry. And you know, actually, you're making me think that maybe I should have covered it in some of the lectures itself. I'm gonna add a note to myself in my course notes to think about adding a lecture on it for next year. By the way, you know, and that kind of reminds me, if there's anything you think that we definitely missed out in the lectures, now that they're all up and online, please let me know, and I'll see if you can, and I'll see if we can get it in for next year. If nothing else. Gustavo wants me to briefly cover my paper. I will be happy to do that. I kind of did at various times during the class because a lot of what we discussed is basically in the class. Wow. Roland and I have written a couple papers together, so I'm having trouble turning it up really well. But okay, here we go. Let's see if I can turn that back on. Okay. So the paper we wrote, it's in the International Journal of Research and Marketing, but it's really kind of widely applicable. It's just that a lot of the examples are in marketing, right? The general idea, it basically goes over in many ways the same thing that we discussed in Unit 5, the development of a simple diffusion innovation model. But it does it by first laying out how to build a model rigorously, and then how you would go about doing that, right? And it starts off with a discussion of how agent-based modeling is related to other types of modeling: analytical modeling, empirical modeling, consumer behavior. Primarily modeling methods that are well covered within the marketing context and the business context, right? And kind of some of these things you should be aware of now, right? Like agent-based modeling, the results are less generalizable maybe than some analytical models, but you can build much more complex models, right? And the argument is that, one of the arguments that Roland often makes is that as time goes on, right, the cost of computational methods goes down, which increases the amount of benefit you can get to it. So if you were to choose a Pareto optimal solution, it might be that as time goes on, agent-based modeling is a better optimal solution. We then go through a bunch of research application areas that we think would be suitable for ABM, including diffusion of information, retail location decision making, interfirm relationships, and so forth. But the important part is we then go through how to determine if agent-based modeling is appropriate, and this is the same rules I gave you before: medium numbers, local and potentially complex interactions, heterogeneity, rich environments, temporal aspects, and adaptive agents. Right? And then we talk about how to build a model. Right? And the first goal is decide if the model is appropriate, then design the model. Right? And this is where there's some relationship to the OUT protocol, right? Because we talk about you should describe the scope of the model, the agents, the properties, the behaviors, the environment, input and outputs, and time steps, right? The very things that I'm asking you to do for the final project. And then construct the model, right? And we show how we constructed the BAS model. And then once we've gone on, so we say, now we have a model, what do you do with it, right? So the first thing you have to do is verify it. Well, this is something you don't actually do after you build. You do this all along the way. And we talk about that you should do documentation, programmatic testing, this isn't all the way up, test cases and scenarios, which we explored in Unit 7 when we talked about verification, right? And then we go on to talk about validation and how you should do microphase validation, macrophase validation, and this is all what we talked about in Unit 7. So I never once covered this paper completely during the course, but basically every part of this paper is at some point distributed throughout the class that we've talked about. Then we show how our model reproduces the original BAS patterns of data, and then how we can break the model to look at social networks and how that changes the results. Okay? So as Okay, we're back. Sorry about that. It looks like something happened where when I was flipping between all those screens, it killed my streaming software. So we're back on now. Okay.
Um, so anyway, so that gives you an idea. Like what I was trying to say just before I got cut off, and maybe you heard it, was that no single, there's no single place where I cover all this, but it's been distributed throughout the entire class. And Gustavo was saying that it'd be great to have research methodology as an additional class or additional lecture series. I totally agree. In many ways, I feel like that is kind of what like Unit 7 is really discussing, right? But we could potentially, maybe in the advanced topics, for instance, go into more depth about some of those concepts. I could see how we might want to do that. Okay, let's see. So that's all the questions I have in the YouTube live chat. Let's see if there's anything else that's come up on Twitter or anything. Not that I can see there. There have been some interesting stuff coming out recently. There's a new book, by the way, that came out from some researchers based out of Asia on agent-based modeling and network dynamics. It looks interesting. I ordered a copy for my Kindle to take a look at it, but I haven't gotten to it yet. Okay. Anyway, okay, so that seems to be about it. If there are any other questions, let me know. I'm looking to see, most of the questions in the forum seem to be around the idea of how to of getting the assignments in on time and what the deadlines are, and I kind of already covered that. I'll do it at the very end again just to make sure we went over it. There is, some people did suggest, and this is kind of a good suggestion, that when you do your final peer review, make sure, why don't you just go ahead and paste the 5-digit ID in at the front of the field so that everyone makes sure that you're reviewing the right one. Yeah, I think there was one question, there was one comment I saw. Hold on, let me see if I can find it again about reproducibility and replications. Let's see if I can find that comment, the question again. Okay, so okay. No, I'm having trouble finding it for some reason. That's interesting. Maybe I can just search for it. Okay. Oh, there we go. So Miguel actually had posted to the forum, I thought, an interesting comment about how he had read the paper that I wrote with Uri on making models match and about replication. And there's this problem that people are not, there is not much of an incentive to do replications, which I think is a bummer in some respects. There's a lot of good work that's done on replications, and I wish that there was there were more journals that would publish replications. Now, actually, marketing does have, it's in, I'm not going to remember the name of it right now, but there's a journal called Consumer and Market Behavior, which actually has something called the Replication Corner. And so for marketing related replications, they will actually publish it. And it actually used to be an IGRN, and it moved over to CMD instead. But there were hundreds of publications in there over the last couple of years on replications, right? The problem is that journals have this incentive to try and publish top-breaking research, and the truth of the matter is that people don't cite replications very often unless they show something horribly wrong with the original model. There have been some great examples of papers published that have shown that one of the original models was wrong, and they wind up getting cited quite a bit, right? Even more in some cases than the original model, right? The example I'm thinking about is like the hoteling model, for instance. That was originally there's been some mistakes found in some of the original math and Hotelling's model and the follow-up version. So the Hotelling model, just to quickly describe, what it basically was this model that said that if you assume that people are distributed along a line, right, then you can figure out where the optimal location of two companies should be along those lines, to basically explore where the socially optimal location, right? And what they showed is that and what Hotelling originally showed was that the two agents should be close to each other, if I remember correctly. But then the Aspermont paper, which came out later, right, showed that they actually should, under some conditions, should be farther apart, right? So that was a very interesting finding. I'm trying to find the Aspermont article, but that was a case where a replication of an original model actually shows that under certain assumptions, the exact opposite was the case, right? Yeah, and I explained that right. I did. I'm looking up real quick, but the Hotelling model shows that they should be as close as possible to try and get to the maximum agents, but the Aspermont showed under different conditions they should be as far away from possible, right? So that's a great example of a case where a replication does really well. So if your replication does show that the original paper has some issues or some assumptions under which it changes, then I highly recommend going back to the place where the original paper was published, because often they're interested in publishing a follow-up to that original paper, right? Another example I can think of this is that Rick Riolo and Bob Axelrod and a few others had this great paper that was published in Science or Nature, I can't remember which, that basically talked about how you could evolve cooperation without having these explicit tags in these systems. And they basically showed that it worked very well and was very robust. And then there was another paper that basically showed that if you had these negative threshold values, which was a completely different assumption, you would not evolve cooperation, right? And they were able to publish that. So if your replication just confirms the original author's results, it's very difficult to publish that. I believe there should be a way to do it. I just, it's hard to do. I would recommend, if you find like, oh, the original author just did this perfectly, try and figure out how to extend the replication, right? Try and do something else with it, and basically then publish that, right? Basically say, look, the vast majority of this, we're confirming what these authors say, but here's something they didn't look at that we're going to look at, and we show how it might add on, right? And I think that's the best way to get replications published. That's one thing I wanted to mention, right? So other than that, there are ways to publish just pure replications at times. If you can get, another thing you can do is if you can get a bunch of replications together, right? And there's been a bunch of evidence of that recently in the psychology field, right? And then talk about kind of what those replications say about findings, right? That's an interesting way to publish as well. So Jerry has a comment. At one point you mentioned easy way to capture documentation in our code. Did I miss that? Sorry, Jerry, I'm not exactly sure what you're talking about there. What I do is I comment as I'm writing the code, right? Like I might go back and clean up my documentation later, but I do as much as possible. I try and comment the code as I'm creating the code, because I find if I even give it one day, I sometimes, maybe because my memory's not that great, I sometimes forget what I was trying to do. And so having the documentation there is possible. I also, by the way, I always keep an Evernote. I use Evernote, but you can use whatever note-taking software you want. I always keep an Evernote window open at all times when writing code, and I actually describe what I'm doing at the same time in that Evernote window. So I kind of not only have the low-level documentation in the code, but I now have a working document that I can quickly turn into the info tab, for instance, right? Because it has everything I was trying to achieve in the code at the same time. more coverage of 3D analysis and models. Yeah, that'd be interesting for sure. That's definitely a topic to think about for next class. I do think I think relating it. I think your next comment, Gustavo, of how to relate it to information visualization, data visualization is important. And I do see that a lot of agent-based modeling, a lot of the interest in agent-based modeling might be moving towards more of the analysis side of things rather than the model construction and visualization side of things, right? So in other words, making sure that you can present the results in a way that are easily understandable. And to some extent, I feel like what I've tried to do in this class is present you with the basic tools for that. There's so many of these topics that literally could be a class in and of themselves, right? I'm sure I haven't even looked at it, but I'm sure there's a Coursera class on information visualization and data visualization, right? I am trying to give you sneak peeks into it, and then try and point you in the same direction as those other courses, right? But yeah, I understand information and data visualization is very important. Any other questions from the stream? Right? I think there were some questions about using extension. Or sorry, actually there were about using different extensions. There's a bunch of different extensions out there. I highly recommend you check them out for NetLogo. NetLogo tries to maintain a page of all of them, but in fact you can't do that because it's open source, so they could be anywhere. But I highly recommend looking around at all the different Azure-based modeling extensions. Yeah, and I do like. By the way, by scanning through the forums looking for any other questions, I like Miguel's very simple way of explaining the difference between MAS and ABM. MAS is a system, and ABM is a model, right? Of course, you now have to describe what a system is and what a model is for that to make sense. But I think that's a very clear way, right? MAS is a system. It's something you're trying to engineer. ABM is a model. It's something you're trying to model a description of something else. Right? So anyways, great little kind of quick description. Okay. So that seems like that's about it. Glad everyone enjoyed it quite a bit. It looks like I've had pretty positive comments. There will be, by the way, some review statements and things like that I'm going to ask everyone to kind of go through, some evaluations that I'll ask you to go through. I'll put all the details for that in next week's email blast to everyone that'll come out on Monday. But yes, in general, it's gone really well, and I hope you've all enjoyed the course. We'll do one more office hour on next Tuesday at 11 a.m. Eastern Time. If you have any questions for that, please let me know. Other than that, thanks everybody for everything, and we'll talk to you more later. Okay? Take care.